Hello guys, this is Dr. K. Mallikarjuna, Associate Professor of Physics, Marri Laxman Reddy Institute of Technology and Management. Today, we want to discuss about Schrodinger's wave equation. In here, what is the importance of the Schrodinger's wave equation and how it will be useful for to demonstrate about the energy levels and what is the ways to rotate or to revolve around the nucleus by the electrons, how he was explained, what are the shape of the orbitals, all those things were explained by this Schrodinger's wave equation, which is submitted as a their potential functions. In here today I am going to discuss about the Schrodinger's time independent wave equation. Today we are discuss about Schrodinger's time independent wave equation. Generally, we know that the particle is associated with wave. Wave is moves like a particle. This is explained by the de Broglie's hypothesis. After invention of these things, there is total physics is renewed or revised as a quantum mechanics. Particularly in quantum mechanics, Schrodinger's plays a significant role explain about the stability of the atom and explain about the orbitals and their shapes and energy levels, how they are quantized, whether the electron present in nucleus or electrons presence or absence in nucleus is explained by this Schrodinger's wave functions and their motions. Particularly, we are representing the particle. Particle have the mass. Mass we are denoted with the small m and it is moving with a velocity v. When you consider that the particle is motion like a wave, here we can say that the Schrodinger's wave function, it should be continuous. Just like that, xi, we can consider the xi is a wave function. There is no physical meaning about this function, but when it is having the xi square, it have the probability that is 1, then it have the significance. Let us consider the particle is moving like a wave. Suppose you can consider the wave that is xi is equal to xi naught into sin omega t minus kx. So this function is explained with respect to x. That is, it is independent of time t. This is depending upon x. Particularly, this x case, you can consider that when you talk about the function y is equal to sin x. This is the sin is the function, we know the where it can starts. That is, it is starting from the origin. That is the reason we can say that here this start with the 0 and it will goes to maximum. That is, we called as maximum displacement of a particle. We are denoted with the, that is xi naught, that is amplitude of the wave. What is that? Amplitude of the wave, we are representing xi naught. This function is continuous. This function is explained by the sine wave. Here, how you can use this function xi is equal to xi naught into sine omega t minus kx. For our general representation, sir, we are having minus kx. Why you are taking minus kx? Because we are taking the particular function, the distance or displacement of the function is x dash minus x. X dash minus x. Here the wave is going with the function of 2 pi by lambda. Lambda is the wavelength and it should be constant throughout the wave. There is no variable for this wave length. This is the constant. Okay. Here we are representing 2 pi by lambda into x dash minus x. That is the changes of the position is x we are considering. That way 2 pi by lambda into x dash. In here x dash case, when you consider moving the particle, it is having some displacement. Whenever you are considering that, this is the generalized distance and this is the extra distance traveled by that particle or it vibrating the particle. Here x dash is the more than x. In here the velocity of that particle is v. Okay, velocity equal to displacement by time. X dash is equal to v into t. Velocity into time. Okay, we are substituting that part. Here x dash minus x is replaced with the v t into v2 minus x into 2 pi by lambda. This 2 pi by lambda enter into here 2 pi v by lambda into t minus 2 pi by lambda into x. We know that the frequency is equal to velocity by time period. Here 2 pi nu into t minus k lambda. Here k is the wave vector, how it is moving, that is explained by. That is the reason we are representing that wave xi is equal to xi naught sin omega t minus kx. We are taking the function psi, it is having the two parameter, that is dimension parameter and time parameter, xi of x comma t and xi naught is the amplitude of the wave. We are considering now time independent. It is not depending upon the time. That's why we are neglecting the time period. We are considering the dimension parameter x. Xi of x is equal to xi naught into sin omega t minus kx. Okay, now we are representing the wave function. Now when you consider that particle under motion, when you consider the particle under motion, it is always changing their position with respect to changes of the position of the direction. Here we are differentiating that function with x, that is dou xi by dou x is equal to omega naught cos omega t minus kx. Because when you differentiate the sine function, what we will get? We will get d by dx of sin x is equal to cos x. That's we know. That is d by dx of sin omega t minus kx is equal to d, that is equal to cos omega t minus kx. There is the function, one more function that is depending upon x. D by dx of minus kx is equal to minus k. We are substituting that part in here. We can say that minus k xi naught cos omega t minus kx is equal to dou xi by dou x. When we can fix the position, that means how it is traveling. We can consider the small path. Now we want to differentiate again. Why? Because of it will give the energy of the particle. In here dou square xi by dou x square is equal to minus k xi naught. When you differentiate that cos function, we will get the d by dx of cos x is equal to minus sin x, just like that, minus sin omega t minus kx, that is again it is the depending parameter of the x minus kx. Differentiation we will, with respect to x, we will get minus k. In before minus k and minus k, we will get k square, and it have the minus function minus xi naught sine omega t minus kx. We will rewrite that equation minus k square xi naught sine omega t minus kx. We know that we consider the wave function xi is equal to psi naught into sine omega t minus kx. That is replaced with the xi. Then d square xi by dx square is equal to minus k square psi. This minus k square term goes to other side, dou square xi by dou x square. This minus term, it comes to this side, that is plus k square psi is equal to 0. Okay, we know that k square or k is the wave vector that is denoted with 2 pi by lambda. Here, according to the de Broglie's hypothesis, lambda, the particle is moving with the wave and it is associated like a particle. Lambda is equal to h by mv. That is mass of the particle m, velocity of the particle is v. Okay, here we are substituting that part, that lambda square is equal to h square by m square v square. Now differentiating above equation, the value of the lambda replaced with that one, dou square xi by dou x square plus 4 pi square by h square by m square v square into xi is equal to 0. We know that Hamiltonian mechanics, the total energy of the Hamiltonian function is E is equal to kinetic energy plus potential energy. We know the kinetic energy is equal to total energy minus potential energy. Here, kinetic energy we are representing with half mv square is equal to E minus V. From this equation, m square v square is equal to 2m into E minus V of E minus V. Then, that is, we are replacing in above equations dou square xi by dou x square plus 4 pi square by h square into 2m into E minus V of xi is equal to 0. Then, now the equation can rewrite like this. Dou square xi by dou x square plus 8 pi square m by h square into E minus V of xi is equal to 0. This is the Schrodinger's time independent wave equation for the particle moving in one direction or one dimension. If the particle moving in 3 dimensions, we may represent it that dou square xi by dou x square plus dou square xi by dou y square plus dou square xi by dou z square plus 8 pi square m by h square into E minus V of xi is equal to 0. Then it may represented what that differential functions with the Laplacian operator, that is del square xi plus 8 pi square m by h square into E minus V of xi is equal to 0. One more thing you can write like this, del square xi plus 2m, that is 2m by h cut square into E minus V of xi is equal to 0. This is the Schrodinger's time independent wave equation for the particle in 3 dimensions.